Hello, everyone. My name is Samir Kamani, and today I'm going to be presenting some interesting features of GitLab that are valuable for various government agencies. Specifically, the one that is most interesting is the development of code in a less than classified environment. So it could be an unclass or lower sensitive environment, and moving that application up to the higher classification environment. So we call it tongue-in-cheek low to high capabilities, but essentially that is what that stands for. Now, with regards to why this is a problem. So today, what might be happening is that you might have a set of developers who are developing an application in an unclassified or a lower classified environment. And moving artifacts for those projects from the lower classification environment to higher classification environment require some amount of effort. And particularly the way that has been optimized is by compiling the entire project or set of projects into one big executable or one big package, writing extensive notes around how to deploy, how to manage that package. All of that information is captured in the lower classification environment, somehow pushed up to the higher classification environment, either through the traditional mechanisms of what is considered sneakernet, or with more modern considerations around how a diode might operate. But essentially, the minimalization of what is transferred is sort of how we have approached the problem in the industry, and we have tried to solve the current problem. Now, what does that really do? What it does is you have teams that are on the lower end of the classification area who you might be interested in hearing from or contributing to the project. So you are having that happen. However, that information remains in that area. The only thing that moves up to the higher classified environment is a fully blown working application. So there are two considerations there. One is a consideration of the agility of how quickly you are able to take information from all these groups, turn it into code, turn it into an application, and deliver it to the higher environment. And that typically is where things go a little bit slower in the current environments, because you tend to do a more of a waterfallish application development lifecycle, where requirements come from the higher classification environment. People from the lower classification environment try and make sense of those, have those conversations, develop the application up to the point where that application is completely meeting that requirement, and then one shot have a chance of moving the entire piece of the functionality over to the higher end. That can cause some obvious concerns, especially with regards to software that is updating more frequently, or if you have libraries that need to be packaged, you have to go grab every piece of artifact, package it properly, and be able to move that up. So that then leads to a much grander problem of what the receiving end gets in terms of the information. So they have to rely on information that is packaged in terms of documents and information that, as far as the specific build goes, what is it that is packaged in there, what is in the product itself. All of that information is opaque to them. There is no transparency in that process. So with that lack of transparency, what ends up happening is it's just burn cycles of each of the teams trying to figure out how to solve a problem that may arise out of that process. The reactionary mode that the teams have to go into to fix the problem, to get that problem packaged once again, or the solution packaged once again and sent over to the higher environment, takes time and continues to add to the frustrations overall and cause other problems there. So this is where GitLab comes in. GitLab has a unique differentiator where this pain point, this specific use case, can really be solved in a much, much simplified way. So as you may already know, GitLab is a single application for the entire DevOps lifecycle. It has everything from planning to source code management, to package management, to actual deployment, to the CI/CD pipelines, to containerization. All of that is packaged within one application. And to support that entire process, we have developed special project export and import APIs, REST APIs. How does this work? The way it works is on your lower classification environment, you would typically run an export job. Now, how is this job typically managed? It could be a bunch of shell scripts. It could be a cron job that can be set up. Or more interestingly, it could be a GitLab pipeline that can be set up to run and export, to generate the tar file, to put it in the appropriate location, and then on the flip side, on the higher classification end, to be able to import that can also be scheduled. Now, what that means is you can encompass all of this functionality within a GitLab instance. You do not need extra tools to be able to do this, except for the cross-domain functionality, which is where we have marked out very clearly that's where we would need something to happen. And typically in a more traditional sense, that's where the quote unquote sneaker netting might happen, which is where that cross-domain magic we have defined on the slide here. Or in the more modern sense, a diode of some sort is implemented so that packages can be left over there and then picked up on the other side. Now, what happens on the receiving end is that there is an import API that literally imports all of the artifacts that are packaged as part of the export and creates a project within GitLab on the other side. So this is an example of a low to high use case that has been implemented at one of the customer sites. And basically, there's a unclassed environment where there's coding going on, there's development of application, management of application, there's some security testing that is done at that level. This is, by the way, a potential way that can be done. The flexibility exists. Whatever jobs you see on the unclassed side could be running on the classified side as well. It really depends on where and how you want to implement it. The biggest benefit here is that the entire repository or the project repository that is in the repo and all the auto DevOps area on the unclassed side can be migrated over to the higher classification side, and all kinds of jobs can be added on either end, depending on where your cost benefits might lie or your process benefits might lie. So that is something to consider. If you have a security analyzer that is charging you by the project that you are running in there, really more interesting might be to actually migrate that to the higher end and run those jobs in that environment so that when the artifacts come out, that they are properly vetted in the environment that you're actually running it in. So that is one other alternative suggestion that we have from this side. But essentially, the way it works is you have your unclassified side where things can be happening. There's a fail fast, fix fast mentality over there. So you could be fixing things and deploying things into an unclassified environment for people to view it. And then at some point, you're packaging that up either as containers or some sort of library or some sort of executable. It doesn't matter. But the fact of the matter is that you could actually send code up through this process and have the entire code as well as the history of what was there on the other side. Now, there are some future state aspects of this, right? So you may want to consider is that we don't rip and replace necessarily. We don't need to. We can coexist with other applications and tools as described in the previous diagram. So if you have a tool like a security analyzer or some sort of a continuous integration component that you want to keep and preserve because you have expended quite a bit of energy building that up, that's fine as a starter, as a first iteration. But as you will be able to see, even in that situation, as soon as you fall out of that one application model, you now have to worry about how to knit those pieces on both sides of the classification boundaries. So that is something to consider. Whereas if everything is in GitLab, then you have a lower barrier of worrying about what is going up to the higher classification, what is not, how is it being managed. All of those considerations have to be thought about. So in conclusion, with regards to the slide deck, and I'm going to go into a demo very shortly, is to maintain a single source of truth. You can then really get to that aspect, right? Is in today's world where you have multiple applications, you might be storing the same information in multiple places. You might have a ticketing system where you're storing information about why you're doing something, where the requirements are, where the user stories are. But then when you modify your code and check in your code, there's probably some sort of commit message that you're putting in as part of the code, which has some valuable information, arguably. And then your continuous integration pipeline is probably kicking up at some point and in a separate system. Well, all of those things are knit to your perfect specifications to be able to perform in concert. Well, you have to replicate that same architecture in a separate environment and make sure that the versions of each of those components are same, versions of each of those plugins are the same. All of that has to be managed. Versus with GitLab, you have the ability to get away from that and have one single application. Same thing with the ATO process, where you have multiple applications. You are worrying about providing a authorization to operate to each of those components, and that's adding to your bottom line, your timeline, and the expended energy and time of all the other personnel who have to be involved in doing that. You have single package to move across networks. The tar file that is generated out of GitLab is a single file containing a vast majority of the artifacts that need to go from one side to the other side. You can have a single user profile across both networks, and that gives you the governance aspects of it, is you don't suddenly have to break that model and have to import it as an import user and do different things around that. And then, of course, you can create pipelines that are specific to that network. So as you migrate the project, you can build out separate projects that mirror the code and do different things with it and add to that pipeline. You can also override the pipeline aspects of the project itself that you're importing. So there are a lot of tips and tricks around implementing and facilitating that sort of processes. It can also be put into GitLab. And last but not least, GitLab is integrated with a PIV or a CAC smart card PKI integration system. So it provides you the ability to have control around who has access to what and how, and all that is also integrated within GitLab. So that is something to consider as well. So single point of entry, single point of provisioning as well with regards to that construct. So now to the demo. So what I have here is a lower security system that I have put together. The assumption is that the developer would be logging in over here. Similarly, I have a higher security system where the operations folks would be to integrate. Notice the address bar is displaying different things, and that is because of the high and low. Also note that both of these machines actually reside on separate networks and don't have visibility to each other. So this example is designed to imitate what happens in real world. Now, I'm going to log in as a developer, and I see a multitude of projects that are going on here. But for the sake of this demonstration, I will go to this particular project called Hello Happy. It has a Node.js application. It has a bunch of files in it. It has a Docker file. It has a GitLab CIMO file. There's instructions on how to actually manage this particular thing. So think about how in your current environment, the instructions go into some sort of a Word document or a Confluence area or something. Well, this can be actually encapsulated as part of your code repository and be stored in here. So developers have easy access to it. They can actually manage things and work on it. Another aspect of this project is a wiki, which is part of what GitLab Projects already provides. Somebody could actually go in and create a wiki and also have that migrate over from one environment to the other, and therefore you can keep things moving along. So if that is the mode of operation that you have currently, we also support that as well. Now, what are the different artifacts that are within this particular project? This isn't just a code repository. GitLab project consists of code repository. It also consists of issues. So think of issues as your user stories or your requirements or whatever you want to call them. But basically, you can have information and details around here with regards to what it is that you're working on. You can also see who it is assigned to. In my case, I'm going to assign it to myself. I can put it in some sort of an epic. I can put some sort of due date on it, put some labels on it. So all the natural features of any sort of planning or management, a work management system are embedded in here. Now let's assume that I'm ready to work on it. So at this point, I would go and create a merge request. So that is another piece of artifact that we capture within GitLab, is a concept of merge request. So what is a merge request? Merge request is actually where the work is being done. So merge request is tied to a particular branch, and it could be tied to a issue. So in this case, that this is not tied to one, but there could be one that could be tied to an issue. It also has a pipeline that has been run as part of this change. And I can go and modify this code right within GitLab by clicking on Open Web IDE, and I will be able to see all the files. Here's my Docker file, and wherever I can, GitLab actually does provide syntax highlighting. So here's a JavaScript file with syntax highlighting, and it's showing me what it used to be, what it is now. In my case, this file hasn't changed, so it doesn't really show any changes, but if I did change something, it would actually show those changes to me. So going back to the previous page where I had the merge request, there are other artifacts here as well. So as part of my developer process, I may have run some sort of a security scan or dependency scan, which GitLab, by the way, already packages as part of its pipeline. And I will go into more details of what the pipeline looks like. And then at the end of it, if I merge this, then I would exactly have a way of merging this back into the master. So the development lifecycle on this lower end is very, very simple. It is available. I also have the ability to have approvers within this area. So I can have a set of approvers who might be interested in moving this forward and be able to see what's going on. So with regards to the pipeline itself, there happens to be a pipeline that was run over here. I can click into that, and what it shows me is exactly what the pipeline results were. So there was a build process that ran. There were testing processes that ran. These were all run in parallel, by the way. So a test was conducted, static analysis, license management, dependency scanning, container scanning, and code quality. All of those tests were conducted on this particular piece of code that's here. In this case, there were some flags that were raised because there were things that probably didn't look right. And I can go look at my security dashboard to see what those vulnerabilities might have come out to be. In this case, I didn't have any vulnerabilities, but I do have some failed jobs, so I need to look at what happened. So assuming that that was all fixed, I probably have some level of pipelines that have been run. I happen to have one that is passed, and this one shows that there was a build, there was a test, and a release was created at the end of it. So that's the other artifact that is available within GitLab that would move over, and that is a releases artifact. So in my case, I actually created a tag for a release, which packaged up the source code. So that is also as part of a tar or zip. And it actually has a pointer to a specific commit, which was the generating release commit that I have. So with regards to the artifacts that are available on my low side, there's much more. There's obviously operations, there's a package registry, which has a container registry within it. There's some analytics pieces in it, and so on and so forth. There's also snippets. Anyway, you can have a script that is run, you can have a pipeline that is run, you can have many different ways of automating this. You could even have a cron job that is run. But with regards to what is actually happening during those steps, it's all API driven. So I have here an application that I use to interact with the API and GitLab. So I may want to first export the groups. So that is functionality that is available. What groups allows me to export are the epics and certain other group level artifacts that I may want to move, like subgroups and names of things, namespaces and things like that. Then I have the ability to migrate a project. So I have a project over here, and in my case, I actually know which ID it is, and I'm going to actually send the request over. So this gives me details of the project that I have. I don't really need this information, but I'm validating that this project is actually a valid project. There's another API where I can search for a project by its name. So that is another thing that I could have done, is instead of using an ID, I could have searched by name, received the ID, and then search for the ID, which is, again, just one other step that I can add into my process. Then from there, I have the ability to export a project. So I happen to have sent an export message. So when I do that, it basically comes back and says, yep, thank you very much. I have a 200 message, and it says, and it's going to actually go and construct the export. So exporting is actually done asynchronously because it could lead to some time constraints with regards to what it has to package and how it packages and all that. But the same API can be run multiple times to see about what the status of that package is. And once the status comes back as finished, it will actually have a file name that is available for us to download. And in this case, I can continue to run it. In any case, once that is there, I would click on the download. And basically what the download does is it allows me to save a specific file. And in this tool that I have, I've actually put it into a specific directory over here. But if you had a cron job or a script, you could easily take this tar gz file and place it wherever you need to. And then the next step would be to actually sneaker net it or to move it through the diode process to your higher environment. And on the high environment, you would have a single call to an API, which effectively imports the project. And in this case, there's a multi-part form importation process. And then let's say I want to name this something like import test 2020. And essentially it's going to go into this group and I have this attached file, the tar.gz file that I may have downloaded previously, and then I will hit send. And essentially it is taking that tar file right now. It has uploaded the tar file and it is in the process of unpacking that tar file. So if I were to now log in into my operations side of the system, so my high side of the system, and go to my import group over here, what I will see is a bunch of projects that I have. And there it is. There's my project right there, import test 2020. It was created about 5 minutes ago, which means that I just created that. And as I click into that, what you'll notice is all the different pieces that I had on the lower classification environment. I have the releases right over there. There it is. It's unpackaged and available for me. All the particular issues that I have. are also available to me, as well as the pipeline runs of what was on the low side is available for me to view. Now, why is this important and interesting? It is very important and interesting because at some point you can construct a separate GitLab YAML file to deploy this code. And so you can rerun all those jobs in the environment where you are to be able to construct the output file and the process and all of that. Benefit of doing that is you are compiling or running the tools that you need to run within the environment that you need to run it. So if it's on the high side, there are some certain security restrictions that may cause early warning signs when you are compiling. If you had compiled it outside of this process, you don't know of those early warning until you actually try and implement it and then realize that there is some barrier that is not allowing you to implement it. So once again, you would have that back and forth. But with GitLab, because you are actually constructing it right here, you are presumably able to get over those right here. And in this construct, you can actually create an issue right over here. You can create a merge request. You can have a code change that you can implement right here. So let's assume that there was an error over here. So I will go and create a new issue. So this becomes a live, living, breathing project on the high side. So I can say error occurred, need to be fixed. And I can have some other aspects that I can put in here to describe what needs to be fixed. And so now this becomes a living, breathing issue on the high side that I'm managing. I can create a merge request over here, which then takes on the process of what I need to do within this environment to fix that particular issue. So once the merge request actually gets constructed, you'll notice that it is actually tied to the issue. Here's my new branch that I've created in this particular environment. I can click on Open Web IDE. I can actually make some modification to the code. So let's take an example where I actually do modify the code here. I have the ability to see the changes within this particular merge request that I may make. And if I'm ready to actually implement this, I can implement them, test them, validate that they actually work in my environment. But here's the big important piece, is the loop back to the development team to inform them that I've actually made these particular changes in this environment to get it to work in this environment that they need to be aware of. I can actually create a email patch or a diff file right out of here, which is a merge request diff file, standard procedure out of GitLab, which then provides me a diffed version of what changes I made based on my specific environment that I may be interested in terms of the code that needs to be changed, and email this to the individual or somehow get it to them so that they can then look at the specific lines of code, make the same modifications in the originating repository, which would be on the low side, and then come back up through the process into the high side and have that become part of a normal process. So lots of benefits over here. As you can see, I can manage my issues. So if I was an operations individual and I'm very interested in exactly what the development team is still working on in terms of the DevOps model, I have visibility into that. Similarly, I can then go create issues that are related to me on the low side and then have those pull up into the high side as reminders that I need to work on something, as well as have that same project overview detail also come in, which is documentation that also can remind me what I need to work on and how I need to work on. All the details are captured in one place and available, and you don't have to worry about things. So with that, I'm going to conclude this video. Thank you very much. And if you have any questions, please let us know. Thank you.